This video presents a test for protecting the concrete product against water penetration into the concrete product, pavers, by applying a hydrophobic coating. This test is not performed according to norms and standards, but according to the simple principle of visibility. It should show the end user in the simplest way how the quality of the selected hydrophobic coating affects the protection of the concrete product against moisture penetration. Without the protective coating applied, water will almost immediately penetrate into the concrete product. The common opinion is that the applied protective hydrophobic coating permanently prevents the penetration of moisture, i.e., doesn't allow water to pass through at all. The common short-term water penetration test, which focuses on the lotus effect, i.e., the immediate repulsion of water by a concrete with a protective coating, contributes to this opinion. In this case, we consider only the moment of water repulsion at the moment of water penetration into the surface of the concrete product, not the long-term resistance of the hydrophobic layer to water penetration. In reality, however, we must say that in the long run, water penetrates through almost every hydrophobic coating, and the correct question is, how long a hydrophobic coating provides protection against moisture, or how long it takes for moisture to start penetrating the protective layer. Therefore, the correct demonstration of the protective properties of a hydrophobic coating is the one that captures not the moment of water repellency, lotus effect, but the long-term effect of non-penetration of water into the concrete product over the time horizon of 1 to 24 hours. Since water penetrates through the protective coating, the question arises whether the hydrophobic protective layer also prevents the evaporation of water from the concrete. The answer is yes, if the chemical formula of the hydrophobic coating and the sourcing of raw materials does not include the vapor permeability. Thus, a good hydrophobic material is a material that has two properties: A. Long-term water repellency, hydrophobicity. B. Long-term vapor permeability. The sum of these two properties is the basis for the quality of a good surface hydrophobic agent. The test is based on the watching of how long the protective layer prevents the penetration of water, and how quickly it contributes to the evaporation of moisture. The idea of the test is easy. We pour as many drops of water as many hours we plan to monitor on a concrete product. After 1 hour, we remove 1 drop of water and see if the water has penetrated. After the next hour, we repeat the procedure again. We will test 2 series of concrete paving slabs. Polished concrete paving stone series on white and grey cement. Concrete paving stone colour mix series. The following hydrophobic protective coating are taken for the test: A, B, C, D. Also, the samples without hydrophobic protective coating, reference, were tested. The surface of all stones is divided into 3 parts for the test for 4 hours of exposure and moisture evaporation. Principle: 1 site, 1 hour of exposure and evaporation. After dividing the surface into sections, we pour water into these sections. Pouring the first section of the polished concrete series. With pouring sample 2 series colour mix, you can see how water immediately begins to penetrate into the substrate of the concrete. With pouring all samples of colour mix series with a hydrophobic layer, samples 1, 3, 4, 5, you can see the effect of instant repulsion, lotus effect. After just a few minutes of pouring water, you can see how the hydrophobic coating works. Materials A and B immediately begin to let water through. To look closely at the short-term effect of hydrophobization on both series, we will perform an additional pouring and observe its behaviour. Water stays and breaks into parts, drops. Water stays in one puddle and doesn't break into parts. The video clearly shows that when water is removed with a sponge from sample 1, it's removed without forming a wet spot. And from sample 2, with a wet spot. On sample 3, water breaks into droplets in the same way. It doesn't stay as one puddle and doesn't leak into the concrete. On sample 4, water doesn't break into parts, drops. Stands in one puddle and forms water spots after cleaning. Now let's look at all 4 samples of the polished concrete series at once. On sample 1, water practically didn't penetrate into the concrete and didn't form a water spot. Sample 2 shows the strongest water penetration and formation of the most intense wet spot. Similar pattern on sample 4. Sample 4 shows moderate water penetration and moderate water spot formation. Now let's see how water penetrates and a water spot forms after an instant water cleaning on the colour mix series. On sample 1, water breaks into pieces after pouring and doesn't penetrate into the concrete. On sample 2, reference, the water instantly penetrates the concrete. On sample 3, the water collects in a puddle and doesn't instantly penetrate the concrete. The same pattern is observed on samples 4 and 5. Let's see how water behaves on all samples after rubbing. You can see that on samples 2 to 3, the water instantly leaked into the concrete. Let's remove water after 1 hour of exposure on the colour mix and polished concrete series, and watch the process of water stain formation. The smallest stain on sample 1. Samples 2 and 3 have visible water stains. On sample 4, water is completely absorbed by the base. Now we have to understand how deep these spots are. To do this, let's observe the change in the water spots for another hour. Also on the colour mix series, you can see that water not removed after 1 hour is completely gone in the concrete of samples 1, 2 and 4, and stayed on the surface of samples 3 and 5. After an hour of drying of water stains, you can see the following. The water stain remained on sample 2, indicating that water penetration was deep and the hydrophobic layer prevents the evaporation of moisture. The water spot is gone on sample 3. This indicates that the penetration wasn't deep. On sample 4, water that penetrated the concrete completely evaporated, which suggests that the hydrophobic coating is good at letting moisture evaporate. Let's remove water after 1 hour of exposure on the colour mix and polished concrete series, and watch the process of water stain formation. The smallest stain on sample 1. On sample 4, water is completely absorbed by the base. Samples 2 and 3 have visible water stains. Now we have to understand how deep these spots are. To do this, let's observe the change in the water spots for another hour. The following conclusions can be drawn from the results of the test. Material A keeps moisture from penetrating into the concrete for the longest time and allows the moisture to evaporate through the hydrophobic protective coating. Material B moderately retains moisture from penetrating into the concrete and allows penetrated moisture to evaporate well through the hydrophobic protective coating. Material C weakly retains moisture from penetrating into the concrete, but allows the penetrated moisture to evaporate well through the hydrophobic protective coating. Material D doesn't retain moisture from penetrating into the concrete and doesn't allow penetrated moisture to evaporate through the hydrophobic protective coating.